Okay, this lesson is on arithmetic series. Now, we talked about arithmetic sequences last class, and so remember in the initial lesson, we're going to go to each individual piece of sequences and series, and today is series. So remember anything about a series? Between a sequence and a sequence is a list of numbers, whereas an arithmetic series is actually the sum of that sequence. So an arithmetic series is a sum, box it, bold it, highlight it, whatever you need to do, sum of an indicated, oops, too many letters there, an indicated number of terms in an arithmetic sequence. If you remember, a sum, an arithmetic series is the sum of a sequence. So if a sequence is a list of numbers, then the series would be a sum of all of those numbers in that sequence. So at first we learned about sigma, right? So you can see it as sigma. Another way to indicate sum is simply with the sum s of n. So in an arithmetic sequence, we used a sub n for arithmetic series, and then for our sequence, sorry, and for arithmetic series, we're going to use s. S also means sum, just like sigma. So we can see it something like this. S of 100 means that you're going to find the sum of the first 100 terms. So similar to the sigma, where you would have 100 on top, it's the same thing. So you'll have S of 100 means that you're going to find the first 100 terms of a sequence and then add them all together because that's a sum. And lo and behold, there is a formula for this. So the sum of the first n terms of arithmetic series follows the formula S of n equals n times t1 plus t of n over 2. So a couple things here to point out. One is the n is going to be the total number of terms. And so that n will also follow here too. It's the same n, so whatever number of terms there are will be the same value for that n. All n's will be the same. T sub 1 should look somewhat familiar. T sub 1 is your first term. In an arithmetic sequence, we use a sub 1, and that was the first term. Here it's the same thing, t sub 1. And then t sub n is the last term. So as long as we know the first and last term, we can figure out the sum of all of the terms. All right. So let's look at a few examples. So the first says here to use the formula for an arithmetic series to find each sum. Now, obviously, these numbers like this, if you were to be given a number like this, you would probably just sit there and add them up. 2 plus 4 plus 6 plus 8 plus 10. I know you can completely do this in your head, but bear with me. We're just trying to teach the formula and how to use it. You wouldn't actually use it for a set of numbers just like this. So using the formula, remember all we need is the first and last term and how many terms there are. So we have the first term, which this is t sub 1. We have the last term, which is t sub n. And we have how many terms there are. N would equal 5 since there are 5 terms. Okay, so we have everything we need. We have how many terms there are. We have the first term, we have the last term. So we have everything to find the sum of this. So we're going to place this in the formula. The formula, again, is S of n equals n times parentheses t1 plus tn over 2. And you just plug everything in. So the number of terms, so since there are 5 terms, this will be S of 5. Okay, you'll place a 5 in for n because there's that many terms. T1 is the first term plus the last term divided by 2. And if you do 2 plus 10, that's 12. Divided by 2 is 6. 6 times 5 is 30. So if you were to add them all up, the sum of the first 5 terms in that sequence is 30. Okay, again, you're not. It would seem silly to use the formula for only 5 terms like that, but again, we're just teaching how to use the formula. Same thing here. So again, identify what it is you need for your formula. I need t sub 1, which is the first term. I need t sub n, which is the last term, and then n, which is the total number of terms. In this case, is 4. So when I go to plug it in, sum of 4, and if you can refer to the formula, it's n is there as well, times the first term plus the last term divided by 2. 5 plus 29 is 34. 34 divided by 2 is 17, and 17 times 4, so S of 4 is 68. So pretty basic. So here's where the issue, and sort of as we go here, things start to get a little bit more difficult. So what happens if you don't have everything? In the previous problems, we had everything. We had the first term, we had the last term, we had the total number of terms, and so we were able to just plug everything in. In this particular example here, I have the first term, so I have t sub 1. This is t sub 1, but I don't have I don't have the last term. Now it does tell me to find right here S of 11, so that does tell me that the number of terms is 11 terms because it wants me to find the sum of 11 terms. So I know that the n value is 11, but I don't know what the last term is. I'm missing that t of n. And you probably, could guess it and figure out what I need to do. Well, I'm going to plug everything in and then just solve for that last term. So we're going to have to go back to what we talked about last class with arithmetic sequences. We can actually, remember, we can find the term of any sequence as long as we know the distance between them. So remember, the last thing we learned about sequences is we can use a formula to find any term within a sequence. So to find the last term, we can use our sequence skills. Our sequence skills were a sub n, which is going to represent t sub n, but a sub n is a sub 1. I don't know why I there. A sub 1 plus n minus 1 times d. So we can find the last term using all this information. So d, we only need to figure out d. Well, okay, the d is the distance or the common difference between these. Since it looks like it's going down by 4 every single time, so my d value would be -4. So I'm just going to plug everything in. If I want the 11th term, because that's the last term and that's the term that I need, I can just say a sub 11 is a sub 1, which is the first term, plus, I know that I'm trying to find the 11th term, so n is 11 minus 1 times -4. So if I do the math here, 11 minus 1 is 10. 10 times -4 is -40, so I have 16 plus a -40, which means that a sub 11 is going to be -24. So what I have done is used my sequence skills to figure out a missing term in a series so that I can actually find the sum. Now that I know the first term and the last term, I have the first term right here. I have the last term right here. And I have the total number of terms, which is, since it's asking for the sum of 11, it's telling me to sum 11 terms. So now I can find the sum. So I'm going to go over here to the left a little bit, if you guys have some room. And I'm going to now use the sum of 11 will equal the sum formula, which is n, times the first term, which is 16, plus the last term, which is negative 24, over 2, and that's it. So 16 plus negative 24 is negative 8. Negative 8 divided by 2 is negative 4. Negative 4 times 11 is negative 44. So sometimes you'll need to find your first or last term, and that you can use your sequence skills to find any term within the sequence as long as you know the first term and the common difference. So over here it's the same type of problem. Again, I don't know the last term. It does tell me to find S of 11. So I know because, and I'll just put over here S of 11. Okay, that tells me that the number of terms I'm finding is 11. So when I do this, n is going to be, switch the pen, n is going to be 11. And I do have the first term here, t sub 1. And it could be anything. I know we keep switching back from a's and t's. It doesn't actually matter the variable. Anything with a sub 1 is going to represent the first term. Anything. A sub 1, t sub 1, b sub 1, z sub 1, whatever. Anything with a sub 1 is going to represent the first term. So I don't have, in order to find the sum, I don't have the last term. So in order to do that, I need to use my arithmetic sequence. So I'm going to be finding the 11th term, and just to reiterate the formula for arithmetic sequence is a sub 1 plus n minus d. Oh, I keep doing that. Not n minus d, n minus 1 times d. And so because I'm finding the 11th term, n will be 11. So I'm going to put this in a sub 11. A sub 1 I already know is negative 16 plus the 11 terms that are in the sequence, minus 1, times the common difference. Now the common difference, what's going on between these, it looks like that it is adding 4 every time. So my d value, and maybe I should write that down, d equals 4. I can plug that in. 11 minus 1 is 10. 10 times 4 is 40. Negative 16 plus 40 is 24. So a sub 11 is 24. Now that I know the first term, last term, and the total number of terms, I can figure out the sum. And so that's what I'm going to do. So let's find the sum. The sum of the first 11 terms is going to be 11 times the first term plus the last term over 2. Negative 16 plus 24 is 8. 8 divided by 2 is 4. 4 times 11 is 44. And there you go. So then we found the sum of that sequence. Even though we didn't know the last number, we could figure it out using our sequence rules, our sequence formulas. So we're going to skip this bottom part. That's not necessary right now. So you can just sort of cross this out. We're not going to do that. And we're going to flip to the back side. Okay. So now let's do some sort of application types of problems. So here, the first application type of problem is the number of seats in the first 14 rows of the center orchestra aisle of the Marquis Theater on Broadway in New York City is in the form of an arithmetic sequence. So the first thing we need to do is actually write the sequence, because we don't know the numbers. What we can just write it. We're only given the first 4 rows, so we're only given the first 4 numbers within the sequence. So if we count the first row, and I'll spare you the actual physical counting, but if you do physically count it, you do get 11 in the first row, 12 in the second row, 13 in the third row, 14 in the fourth row, and so on. With a dot, 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 that means that that's going to go on past what we can see. I mean, we can assume what it is, but we're only given the first 4 rows. Now this tells us a lot, because it tells us that the first row, which is t sub 1, is 11. Our first number is 11. It tells us that the d value, I mean the common difference between all these, d equals 1. It also tells us that t of n, or whatever the last term is, would be t of 14, whatever the term is for the 14th term. Because there are 14 rows, the last row will be t of 14, which means that the total number of terms will be 14, since there are 14 rows. So a lot of things that it tells us. So we have the sequence, we have the first number, which is t sub 1 is 11. We have the common difference is 1 from all of them. We have the last term will be t of 14. Whatever the 14th term is, that's what we're looking for. We don't know how many seats will be in that row, but that's what it'll be, whatever t of 14 is. And because there are 14 rows, or 14 numbers in the sequence, n is also 14. So a lot of stuff given to us. So the first thing we have to figure out is how many seats are in that 14th row. Essentially, we are trying to find the last number, whatever that t of 14 is. So remember how we did this in the previous problems. To find the last number in a sequence when we don't know the last number in the sequence, we're going to use our arithmetic rules. Arithmetic rules are remember a sub n equals a sub 1. I keep writing this formula, but obviously you'll be given it. It's n minus, I keep doing n minus d, n minus 1 times d. So if I want the 14th term, or a sub 14, remember it doesn't matter what variable you use. I know we're sort of jumping around between t's and a's, but that's it doesn't matter with a of 14 or t of 14. The first term we do know, it's 11 plus, and we know we have 11 numbers in our sequence. Or not 11 numbers in our sequence. We have 14 numbers in our sequence. Minus 1. And the common difference was 1. 14 minus 1 is 13. 13 times 1 is 13. Plus 11 is 24. So a sub 14 equals 24. What that means is that in the 14th row, there will be 24 seats in that row. So the next question says, well, how many seats in total are in the first 14 rows? So basically, how many people could you fit in the first 14 rows? That is a summation question. That is where we're having to find the total, or the sum of all the seats in each row, and that's a sum. Basically, you're trying to find the sum of the first 14 rows. Now the formula is n, again, t1, which is a1, whatever, plus t of n, which is the last term, over 2. So s of 14 will have 14 terms in it. The first term being 11, the last term, which we just found, would be 24 over 2. 11 plus 24 is 35. 35 divided by 2, I know this is a fraction, 35 divided by 2 is 17 and a half. So you have 14 times 17 and a half. Don't be worried by that. It'll fix itself, because 14 times 17 and a half is, sum of 14 is 2, that's an equal sign, 245 seats. You should get a whole number. Obviously, we can't have fractions of seats, and a total number of seats should never equal a fraction of a seat. So that's that. So the last problem here is similar. Okay. So Sheila begins an exercise routine for 20 minutes each day. Each week, she plans on adding 5 minutes per day to the length of her routine. For how many minutes goes on to ask the question. So a couple things we need to take note of here. That she's going to start her routine at 20 minutes each day, and then each week she will add 5 minutes to her daily length of her routine. So the first week, each day, looks like there. So it tells us that our first number is 20. And then each week we're going to add 5 minutes. So this ends up being t sub 1, our first term. The 5 minutes per day increase ends up being our d, because that's the common difference. So I know that the next week would be 25, and the next week would be 30, and so on. Okay. Remember that if we want to find any term within a sequence, whether it's the last term, the 5th term, the 25th term, or in this case, the 6th term or the 6th week, we're going to need to use the sequence formula. So the sequence formula, which I like using a, is a sub n equals a sub 1 plus n minus 1 times d. We can use to find the 6th week. So a of 6, or the 6th term, is going to be the first term, 20, plus 6 terms, it's the 6th term we're trying to find, minus 1, times the common difference, which is 5. 6 minus 1 is 5, 5 times 5 is 25, 20 and 25 is 45. So the 6th week, her workouts will be 45 minutes. Now, question B says, what happens to Sheila's exercise routine if she continues this pattern for 2 years? Holy cow, 2 years. So she's going to, remember, she's going to start at 20 and increase her workout plan 5 minutes per week. And now we're asking 5 minutes per day is going to be added each week for 2 years. So we have to figure out, okay, how many weeks is that? So the first week it's only 20 minutes, but the second week it's 25, and then 30, and 35, and 40 for each week. So you have to figure out, okay, well, how many weeks are in 2 years? Well, since there's 52 weeks in a year, 2 years would be 104 weeks. So basically, what we're trying to find is what would be the 104th week. So again, we're using a sequence here because we're trying to find a specific week and what would happen that week. So we're looking at a of 104, the 104th term. Again, we take the first term plus now 104 terms minus 1 times the common difference of 5. 104 minus 1 is 103. 103 times 5, and I have to get a calculator for this. 103 times 5 is 515. So you have 20 plus 5, 15, which ends up being 535 minutes per day that week. Obviously, that's unrealistic. That's an excessive amount of working out. If you're curious, if we divide by 60 minutes, that's 8.92 hours per day. But that's how you would figure that out. So that's it for sequences. Please let me know if you have any questions, and I'd be glad to help.